Hey everyone! Welcome back to the channel. Today, we're diving into something that sounds like it's straight out of a sci-fi movie, the Atlas Anomaly. You might have seen this term floating around, usually next to some pretty dramatic headlines about Earth's impending doom. So, what's the real story? Is our planet actually in danger? Let's break it down. First off, what even is the ATLAS anomaly? The name itself sounds pretty intimidating, right? ATLAS actually stands for Asteroid Terrestrial-impact Blast Alert System. It's a network of telescopes run by the University of Hawaii, funded by NASA. Its job is to scan the entire night sky every 24 hours to find near-Earth objects, asteroids, and comets that could potentially pose a threat to us. Think of it as our planetary defense system, our cosmic neighborhood watch. Now, the word anomaly is where things get interesting. In science, an anomaly is simply something that deviates from what is standard, normal, or expected. It's an outlier, a piece of data that doesn't quite fit the pattern. So, when people talk about the Atlas anomaly, they're not referring to one single, giant, Earth-destroying asteroid that Atlas has found. That's the first big misconception. Instead, the term has been used to describe various unusual observations made by the Atlas system or other sky surveys. Sometimes it might be an object with a strange orbit that we can't immediately explain. Other times, it could be an asteroid that suddenly brightens or dims unexpectedly. It could even be a false positive or glitch in the camera or a satellite glinting in the sun that momentarily looks like a new object. Essentially, an anomaly is a puzzle for astronomers to solve. So, where does the Earth's destruction is imminent part come from? Mostly, it's a mix of misunderstanding and online sensationalism. Let's be real, headlines that say mysterious object baffles scientists get a lot more clicks than astronomers recalculating an asteroid's slightly unusual trajectory. Let's look at a real-world example. A while back, there was a lot of buzz about an object designated C-2019Y4, also known as Comet ATLAS. When it was first discovered, it was brightening incredibly fast, leading to speculation that it could become one of the brightest comets seen in decades. People got excited, but then something unexpected happened. The comet started to fall apart. It fragmented into smaller pieces and faded away, never putting on the spectacular show people hoped for. Was it an anomaly? Absolutely. Its behavior was unusual. Was it a threat to Earth? Not at all. Its closest approach was still tens of millions of miles away. This is a key point. Just because something is anomalous or unpredictable doesn't automatically mean it's dangerous. The universe is a vast and complex place, full of phenomena we're still trying to understand. Comets break up, asteroids can be oddly shaped and tumble in strange ways, and their composition can cause them to reflect light unpredictably. These are all scientific curiosities that help us learn more about our solar system. So, how does the process actually work when a system like Atlas finds something? When a new object is detected, its position is recorded. Other observatories around the world will then turn their telescopes to it to gather more data. The more observations we get, the more accurately we can calculate its orbit. This data is fed into computers at places like NASA's Jet Propulsion Laboratory, which runs the Sentry system. Sentry is a highly automated collision monitoring system that continuously scans the catalog of known asteroids and calculates their future paths, looking for any possibility of a future impact with Earth over the next 100 years. If a potential impact is detected, it gets listed on a public database called the Sentry Risk Table. Now, before you panic and start checking this table every day, you need to understand how it works. When an object is first discovered, we have very little data. Its calculated orbit has a large margin of error. So, the system might flag a tiny, 1 in a million chance of an impact decades from now. But here's what almost always happens. As more data comes in over the following days and weeks, the orbit becomes much more precise. That initial, tiny risk almost always drops to zero. The object is removed from the risk list. This happens all the time. An initial anomaly in the data gets resolved with more information. It's science in action. It's not a sign of imminent doom. It's a sign that the system is working exactly as it should. It flags every potential risk, no matter how small, and then refines the data until the uncertainty is gone. Think of it like this: you're driving, and your GPS says possible heavy traffic ahead. That's the initial warning. As you get closer, the GPS gets more real-time data and updates. Traffic is light, you're on the fastest route. The initial anomaly, the possibility of a traffic jam, was resolved with more information. You wouldn't pull over and abandon your car just because of that first warning, right? So, back to the big question, is Earth's destruction imminent because of some Atlas anomaly? The answer is a resounding no. There is no single, verified object, no Atlas anomaly, that is on a confirmed collision course with Earth. NASA and other space agencies are very transparent about this. If there were a credible threat, you would hear about it from official sources, not just from a random YouTube video with scary music. These organizations have a very clear scale for communicating risk, like the Torino Scale. It's a color-coded scale from 0 to 10 that rates the potential threat. 0 means no hazard, or that the object is likely to burn up in the atmosphere. To date, no object has ever been rated above a 4, and even those were quickly downgraded to 0 as more data became available. Currently, everything on the risk list is a 0. It's also important to remember the sheer scale of space. It's incredibly empty. While our neighborhood watch systems are getting better and better at finding even small asteroids, the odds of a major impact in our lifetime are extremely low. Scientists estimate that an impact from an asteroid large enough to cause global devastation happens on a timescale of millions of years. We are far more likely to face challenges here on Earth, like climate change, than we are to be wiped out by an asteroid tomorrow. The work being done by ATLAS and other survey programs is incredible. They are mapping our cosmic environment to protect us. They find anomalies, they investigate them, and in doing so, they make us safer. The sensationalism surrounding the Atlas anomaly is a distraction from the real, fascinating science being done every single day. These astronomers are the real-life heroes, working quietly in the background to ensure our planet's safety. So, the next time you see a headline about a mysterious anomaly hurtling towards Earth, take a deep breath. Remember that anomaly just means puzzling, not apocalyptic. Check the official sources like NASA's website, and appreciate the fact that we have dedicated scientists and amazing technology watching the skies for us. The Atlas anomaly isn't a harbinger of doom. It's a testament to our curiosity and our commitment to understanding the universe and protecting our home within it. Thanks so much for watching. I hope this cleared things up and put your mind at ease. If you found this helpful, please hit that like button and consider subscribing for more deep dives into science and space. Let me know your thoughts in the comments below. Stay curious, and I'll see you in the next video.